Hi there, we're doing bi-weekly contest 32 Think Out Louds. We've got the two questions, the first two questions. Feel free to check out the video. We're going to start with the minimum insertions to balance a parenthesis string. Alright, so given a parenthesis string S containing only characters opening and closing brackets, a parenthesis string is balanced if any left parenthesis must have a corresponding to consecutive right parenthesis. A left parenthesis must go before the corresponding to right parenthesis. For example, this and this and this are balanced. These are not balanced. Right, so I think I have already done this question before, but the one with a single closing parenthesis, but I don't think that it's good. There's going to be any major difference because of that. Now it says you can insert the characters this and this at any position of the string to balance it if needed. Okay, I've just checked whether or not they're balanced in the question I remembered. Return the minimum number of insertions needed to make S balanced. Oh, okay. Okay, I've not done this. Alright. So we can add them at any position and we need to make it balanced. So generally so this is like a very famous problem, the opening and closing one and checking whether or not it's balanced. It's generally done with a stack where you keep pushing the opening ones and whenever you get a closing one, you just pop it out. If you have a closing one without a corresponding opening one, then it's invalid. So basically that's the idea, but how can we do this? All right, so I think we're gonna do the same thing. We're gonna have a stack, and if we encounter a closing without an opening, we're just gonna add a opening bracket. And if we are left with some opening brackets without closing brackets, we're gonna add the corresponding closing brackets. So that's double the number of elements we already have in the stack at the end of it. I think that should be able to deal with this. I think that might just work. Yeah. So we just need to have a stack. So in a previous Think Out Loud video, we figured that from collections, if we import DQ, that just might help us achieve this. Let me check on a terminal once. Let me quickly clear this video and start a new interactive shell. Yeah, so from just gonna copy paste it from here. Right. Um, okay, so the import is correct. The rest we probably would be able to get it right. So I'm still new to DQ. I've not used it much, so that's why I'm a little hesitant towards it. All right, now S is given as a string. So okay. But we could even okay, so there's a little bit of a challenge here. So we might be given with just one closing bracket, right? Even though it's a character, it can be there, but that would kind of be invalid for us. So whenever we encounter such thing, we'd have to add a closing bracket there, otherwise it would be an invalid string. Yeah, can't have that. Okay. I think we're ready to get started. So, all right, a little bit tricky. So I was thinking for characters in S, but we can't do that because we want to read two characters at a time when it's a closing bracket. So we're gonna have initialize our answer by 0, and we're just gonna keep incrementing this whenever we encounter any um, unbalanced unbalanced string or unbalanced part of the string. Anywhere we get that, we're just gonna keep increasing this to fix the string. We're not actually gonna fix the string because, and there are gonna be multiple ways of doing it, but the number of changes is what we're gonna calculate, and that should be enough. All right. So we're gonna do it this way, that I'm gonna initialize a pointer with, like, not a pointer, just a variable storing the index. And while I is less than length of string, we're gonna keep doing it. If s of I equal to okay, an opening bracket, then our, our st, which is the string that we are considering, is going to be this. But if it's not, then we need to be careful. Then alright, so we might not even have I plus 1 available, because we check if I is less than length of str, right? So we're gonna do a else here. Now if s of I is not this, then sorry, yeah, then s of I must be this. Now there are only two cases, or three cases, that I plus 1 equal to the length of s, lf, else if, lf. I think it's lf in fact. I'm not sure. I think else if. Alright, I think we're just gonna go with else if and see if we get a syntax error, then we're gonna fix it. So else if s of I plus 1 equal to a closing bracket and an else. Python if else if else. We're just gonna check the syntax just to be clear. Let's just not use a, what do you call it, syntax error to figure out whether or not we're right here. Just a quick check needed, nothing else. If else elif, okay. Oh, I think both of them are allowed, even else if, because it says it's short if that. Alright, let's just be clear with it and see if else if works. If it's this, then answers plus equal to 1, and we set the st equal to 2 closing brackets. If it's a closing bracket, then we just set I plus equal to 1 extra 1. It should normally increase at the end of it, so we bump it up one more, and we set st as double closing brackets. Else it's something like this, which it would be invalid, so again answer would be plus equal to 1 and st will be this. Alright, so we have a lot of redundant code here. Let's try to fix that up. Okay, now okay, let me just run this code once to check if there's a syntax error. Yeah, invalid syntax. Okay, my bad. Let's do it as lf, and this is okay. So in all three of our cases, our string is gonna be the closing brackets only, and so let's just get this out of each of them, and I should increase here. I should also increase here, right? No, sorry. Huh. Tricky. It would be the last iteration, so I don't think it matters. Yeah, but it doesn't really matter. Yeah, I don't think it matters. Does it? Okay, let me just think over it. We're gonna process this token st, so, and that's the last token anyway. No, it doesn't matter. So we're just gonna set answer as plus 1. If it's already this, then we're just gonna read that and skip it. else we're gonna insert one. So we're not gonna skip the next character because that's an opening bracket, right? All right, cool. So okay, if I plus 1 equal to length of string, or s of I plus 1 equal to opening bracket. In both cases, we're just going to do answer plus 1, else we're going to do this. Does that make sense? So if this happens, then it's already true. If this does not happen, then it checks the next character. If it's opening bracket, then answer plus equal to 1 because we want to add a closing bracket again. And we don't change I, otherwise we change I. Okay, sure. And we're just going to move this up here. Yeah, so this should be fine. Now we know either ST is an opening or a closing bracket. All right, now what do we do? So we don't even need a stack as such. We can just keep a counter of how many opening brackets do we have, right? Because whenever we get a closing bracket, we're just gonna take it out, right? So let's just get away with the stack, and we're just gonna do it as stack length, and we're gonna set it as 0 again, and we can also just put all of the in one line. STL answer and I 0, 0, 0. Right, a little bit neater code, and let's set this as okay, cool. No, we don't need to change that. Now if sf if st, we're just gonna set as st as these two strings, right? Yeah. So if st equal to an opening bracket, then what we're gonna do is just stlen plus equal to 1. There's absolutely no problem here. We can keep opening as many brackets as we want at any time. Now if we have a closing bracket, on the other hand, else, now if stlen is greater than 0, then stlen is just minus equal to 1 otherwise. So what do we have now? We got a closing bracket, but we don't have any opening bracket corresponding to it. So we can just add an opening bracket just before the closing bracket, and that would opening bracket is just one length, so that would increase the answer by 1. And at the end, when we're done with everything, if our stack length is not equal to 0, I don't even think we need to check this. We're just going to do stack length into 2 because for all the opening we need 2 characters to close it. So we'd add this to the answer, and if it's 0, then it would just remain like that. So let's just see if it works on the sample test cases. Alright. Okay, so we did something wrong and we need to figure out what. We got a 0, 0, 1, 6, 0, and the first one's 1. Okay, we have 2 openings, 1 closing and 1 impartial one. Now we can probably do a dry run of our code. So dry run comes extremely helpful in cases like these, when the test case is small and it's failing and you need to find out why. So I'm just going to paste the string here for simplicity. Now we have this as the string. We set I as 0 in the starting, so it's going to read this. It's going to go here, set st as this opening bracket, go to this place, increment I, so I is going to be 1 after this point, and if this is opening, which is it's going to set stlen to 1. then it's gonna go to the next place. Again, do the same thing with this position, set stlen is 2. Then, so at each time, let's print, just to be absolutely sure, let's print I, let's print stlen. So I stlen before, and we'd have an after, yeah, and we'd have an extra enter for ease of reading. Okay, I think this should give us something nice. Yeah, cool. So I equal to 0, st length got from 0 to 1, I equal to 1, st length got from 1 to 2, I equal to 2. Right, so 0, 1, 2, now we're here. Now I equal to 2, then I should directly go to 4, that makes sense, and st length became 1 because we popped 2 characters out of it. We went to else and we saw this. No, we came here and we increased I one more, so we're gonna reach here 0, 1, 2, 3, 4, and the length of string is 5, so it's gonna also run for I equal to 4, and before stlen is 1, and afterwards it's 0, but it should have increased the answer. So okay, how come answer is wrong then? We're getting 0 as our answer. Okay, we need to over it again. Something's going wrong. I'm not sure what. Print here. Run code. Alright, so at the end it's going to the first one, it's incrementing answer. We're returning the stlen. My bad, sorry. Sorry, that was a silly mistake. My bad. Let's remove all the print statements, commenting them for now so that we don't make another mistake and have to write everything again. Alright, guys, be careful what you're returning. 103.12.5, 103.12.5. Okay, we have got the test cases right, so we're just gonna get rid of all these debugging statements. Okay, let's submit the code and see if it works. Oh, we got it accepted. Thank you for sticking with the Think Out Loud. I'm gonna see you next time. Bye bye.